Diesel fuel is any liquid fuel that is used in diesel engine that don't require a spark plug to ignite it. It is made from a variety of sources, but majority of them are made from petroleum. While being beneficial to us by providing us with energy and powering many vehicles and equipment that we use daily, it also releases several harmful gas emissions when burned. Therefore, scientists have introduced us with a better alternative that provides us with the same amount of energy and is used in a similar way as the normal diesel fuel. That is biodiesel. Biodiesel is a fuel similar to a regular diesel but is made from plants, animals and sometimes wasted or used cooking oils. Compared to a normal diesel fuel, it reduces greenhouse gas emission by up to 86%. It is environment friendly, non-toxic, and during its production, it also releases less harmful wastewater and hazardous waste. Therefore, biodiesel is an ideal product for the diesel consumer.
We wonder if we could extract a biofuel from other green photosynthetic plant with some lipid content, as we previously noted that a biodiesel can be created from a basic plant-like organism such as algae. Lipids are a volatile component of plant. According to studies, they generate energy for metabolic process, serve as membrane structural component, serve as key intercellular signal. Biodiesel can be made from any fatty acid source. As a result, any animal or plant lipid should be really substrate for a biodiesel generation. Thus, we assume that all the plant can produce biodiesel in this case. The method of manufacturing biodiesel through the chemical reaction of trans-esterification, and esterification is known as biodiesel production. This is accomplished by reacting vegetable or animal fat with oil and short-chain alcohol using methanol and ethanol. Alcohol with low molecular weight should be used. Although either acid or base can catalyze the trans-esterification reaction, the base catalyzed reaction is more prevalent. Methanol and sodium hydroxide will be used in our case.
Now I will be showing how to prepare biodiesel using algae. Here we have ethanol, hexane, sodium hydroxide and algae. First we mix algae and hexane together. Hexane helps in extraction of oil. Then we mix ethanol and sodium hydroxide in another test tube. At last, we mix them together. When we mix ethanol and sodium hydroxide together, it results in the formation of alkoxide, which execute on nucleophilic attack on ester present in lipids. Our final result will be eco-friendly biodiesel.
Now I will be explaining the mechanism of the chemical reaction that occurs during production of the biodiesel. So the name of the chemical reaction is trans-esterification. During the reaction, the alcohol and the base that we use reacts with each other, leading to the formation of an alkoxide ion. This alkoxide ion executes a nucleophilic attack on the ester, which is from the lipid. Here, the double bond breaks and a positive charge is deposited on the carbon here. And the alkoxide here binds to the carbon. This leaves us with an intermediate product. From this intermediate product, this alkyl group along with this oxygen leaves, which results in the regain of the double bond between the carbon and the oxygen. Lastly, we are here with a new ester and a new alkoxide ion. So the main product that we are trying to achieve is methyl ester, which mainly compose the biodiesel.
We used alkane liquid sodium hydroxide and methanol in our first experiment, but it was unsuccessful. So in our second experiment, we used the identical reactions with the exception of sodium hydroxide, which we replaced with a solid version, because apparently studies have shown that the presence of water causes unfavorable base hydrolysis. So we made an effort to use as little water as possible. However, we were still unable to achieve the desired outcome. Finally, we were able to obtain the results after adding hexane to the reaction, which is utilized for oil extraction to extract algal oil. After that, we added 5 additional green plants including grass, parthenium, guava tree leaves and 2 others to replace the algae. Later, we performed the same experiment using the same biomass, but here the evaporated the hexane we used during the experiment. Fortunately, every reaction worked and we were able to obtain easily ignited diesel. After analyzing the findings, we came to the conclusion that biodiesel can be produced from any green plants. And we now have another way to employ weeds and undesired plants to create a very valuable environmentally friendly product.